Hello friends, welcome to my channel. Today we will discuss about pattern matching and I'll touch upon various tiny little things. For example, if let, while let and mixing between different syntaxes. In the previous videos, we have seen how we can use pattern matching using match syntax. Match is very commonly used, but we will try to learn more about various simple shortcuts which will make your life easier. Now let's get started. Here I define a simple variable favorite color, which is of type option. And the data type, the payload, it can contain like ampersand string or ampersand star. So this option is a enum type, which has two value. One is none, another one is sum. And in this example, I am starting with none. Or you can use like some color. Okay. So by default, this sum and option are part of the prelude. So we don't need to import explicitly. And this particular sum is same as like option colon sum or colon none. So this is like enum type. The favorite color contain the data of green. And if the favorite color doesn't contain any color, that we can denote using none. And using the previous match syntax, we can able to identify that favorite color having some content, it contains some data, or it has none values. But I'll show a simpler syntax using if let, how we can compare and extract these green values from this enum type. Now I have a one simple variable, a boolean type is employed, which can contain false or true. This is a very simple primitive data type. And this should be slightly trickier. I could have used like integer like as directly. I can assign value, for example 24, using unsigned integer 8-bit unsigned integer type, or I could use I32 or 64 and so on. But for example, imagine a scenario where you get that data from user input, maybe in the command line interface or maybe from a form element. The data usually we get as a string. So the 24, this is by visually looking, we can say that it is a number. But there may be a probability that we may get, some character as well. So if you try to cast it to an integer, this will fail. If it is a 24, so this can easily convert it to a integer value. So this parse will exactly do the same thing. We should convert this parse this string slice into another type. In our case, another type is a integer. Whatever the explicitly we mention over here, it will try to convert it. If it can't convert, then it will throw an error. And also this parse will return a result. And if you see, this result is of also enum type, enumeration, and which is like two value. If for example, option contain two value. One is sum with some payload and none with no payload. But result has two type. One is okay with payload and error with different payload. So there are two generics type we mention over here if you see that. But in case of option, which is only one generics type. In case of option only some contain the data. None doesn't contain any data. But in case of result, both OK contain the data, which is represented by U8, and we are just ignoring this underscore means ignoring, because we are not planning to do some error handling. But in case you are planning to do error handling, you can have assign some type, for example error type, or some type specific to this parse generics, whatever it is expected, and that value we can extract from error. Okay, and how to and let us explore some if else condition to properly evaluate various different variables. So in our case, favorite color is a enum type, is the option type. Option is a kind of enum. We can very well using pattern matching like match syntax, but in case of match syntax it is very verbose. We can use match, favorite, and we can provide different arms. For example, one arm is for handling the sum value, one arm is handling the num value, which already we discussed in the previous video example. But if you want a simpler syntax, you can use if light, and it is slightly different. This is not a equal operator. This is not a equal operator. It is not a simple if. It is trying to match that type, whether this favorite color contains some data or not. This is a kind of expression. It will evaluate, and the data, this green, will be stored inside the color. Okay, so if favorite color is none, this is inside this code block won't get executed. If favorite color contains the sum with some payload, then this particular statement will be evaluated to true, and this code block will be executed. And also one point is to remember is that this color will contain this payload. That is very important. This you cannot achieve using a normal if condition. If you are trying to compare a enum type, for example option or result, you have to use if light, or also you can use else light as well, what we will see in a few minutes. And I'm trying to print that favorite color. Now let's execute it. This favorite color is green. Now before I put some other condition, now let me convert it to none. If you use some value, always this if condition will be executed, else block won't be executed. But I want to demonstrate that how we can have that else condition also. If you see here, it is a simple if else if. This is a if condition, else if, but it is a if light and else if. This is the important concept I would like to put stress upon. Like we can mix and match between if light and else if as if they are part of same concept, but they are slightly different. If light is for the pattern matching, only one arm it will match, whereas else if is going to evaluate a condition as a boolean value or not. For example, else if you will check like if employed is true or false or not. For example, in this our case false, so this code block won't get executed. If you try to execute it here, nothing will be printed. Here I change this color to none, so this code block won't be executed, and this is also false, so this also won't get executed. So nothing is printed. But if you try to change it to true, so this statement, this println statement got printed. Now let's revert it back to again false. Now let's evaluate age. And the important thing is to note over here is the age is not a variable, or it is not a integer type, it is not a primitive type, it is of type of enum. Okay, so age may contain some okay value, or it may contain error. because we don't know that parsing of the statement is successful or not. So in this case, we again have to use like pattern matching. So wherever you are dealing with enum type, you have to use pattern matching. So then in that case, we can't simply use else if age equal to 24. We cannot use it. We have to use pattern matching. Here, because we are in the else block, instead of using if let, we can use else if let. So if you see else if let, this is a new let keyword you have to pay emphasis on. And because like this sum is of type of option, so you cannot use sum everywhere. Because this age is of result, so result can contain two things. One is okay and second one is error, ERR. Both contain the payload. So you will compare with the age. If age contains some data which is a valid scenario, then this get executed. And this age you will contain the value. We can reuse the same variable because Rust given the ability for set of variable. This seems to be slightly complicated or confusing to beginning with, but it will help us to make the code cleaner and not to overuse lots of variable. Or you can use my age or something, but you have to, it will look different, lots of different variable for same purpose. Till this point, age is a result type, but because we are reusing it, if this condition match, this age will contain this payload of U8. So here, this is the important concept, else if let. Inside that code block, we have written a simple if else condition, because at this point age is a unsigned integer. So you can compare using like age. Normally you can compare in any programming language. If it is greater than 30, print this, and if it is less than 30, print this one. And if you see our age value is 24, then this line will be get printed. Young dude. But if you want to change this value to something bigger number, let me save it. This you are oldie. And if you want to put error, that means parsing. And one important concept is to remember that there is no exception inside Rust, so it won't fail at this moment. In other programming language, if you try to do this kind of invalid operation, it will fail at this point itself. But it will give you a different, cleaner mechanism to handle the error appropriately. So this condition won't be evaluated for us, because this age is not same as okay with some payload. It is having error with some payload. Okay, now this if block want to get executed, and this else block will be executed. Good for nothing. So you see the example in this part, like if let, and you can mix match with different normal if else condition, and you can use else if let as well. And we know how to handle option and result. I think this should be clear, and we'll proceed to the next thing. You can use this pattern matching inside loop as well. Not actually, there are three type of loop inside Rust. One is loop, which is kind of infinite loop, and second one is while, and third one is for loop. And you can use let only along with while let. There is no for let concept. Only while let is possible. Now let's see some example where we can leverage this while let. So I have defined a simple vector. I initialize a vector with alphabets, and I put it mutable because I want to add some data inside this alphabets, for example A, B, C. But at this moment, if you see, the type of this vector is unknown, but it is not an error. Once we started putting some value to the alphabets, the type would be auto inferred depending upon the first data we inserted into this alphabets vector. So we have added A, B, C as 3 distinct elements inside this alphabets vector. Now we want to loop through it, and we want to retrieve one value at a time. So corresponding method for post is pop. Post to edit, pop to remove that value from alphabets one by one. It is not accessing, it is just removing or completely taking out of it. So alphabets will be, that element will be removed, and it will be, if you try to do pop, so C will be removed first, and B then A. In this case, pop will again return option, this option enum. Wherever a particular function is returning a enum, you cannot use a simple file condition, or this is a conditional string. So you cannot simply use like top is equal to pop, or you can't match with C or B or A. So you have to use let, because in this case pop is returning a option. So option, again I am stressing this point, option may contain sum with payload. Means if it is successful, it will contain sum with data C, B and A. And if the 3 data is already extracted, then it will return none. What we're trying to say that you try to pop it, you try to get the value, and if it is contains some payload, then you evaluate this, whatever the code inside this code block you are going to write, you execute it. But if you reach end of this vector or end of this array, then this particular pop will return none. Then this condition will evaluate to false, and this loop will be exited, or this loop will be terminated, so that the code block won't be executed. So again, pop will return option enum. Option enum contain 2 value, like one is sum with payload and with none. So this that's why we are comparing with sum with payload. This variable top you can give any name, like A, B, C, D or whatever may be variable. This is a variable naming convention. And this is auto inferred. This is string type, static string. Let me debug it. Let me execute this. If you see that, pop will remove the last element. A, B, C we have inserted in this order, but while retrieving it using pop, will be going into reverse direction, like C, B and A, and after that it will become none. Then this loop will be terminated or exited. So the code block will go to this point. Now using vector macro, this is the same thing, like the same stuff like up to this one. Whatever is there, this is the same thing. But I have declared and initialized the vector in the one line. But if you notice over here, this is a vector macro. This is not a simple standard library thing. This is a vector with V capital. Here we can initialize using new keyword. But using this macro, this internally will do the same thing. This macro under the hood, it will perform the similar kind of stuff. But that is a simple thing. So we got the alphabets. And before this example, I saw the file let, and now I'll show how to loop through the for loop. And for loop, there is no concept of for let. So we have to call different function inside vector to get that value and loop through it. So to looping through this using for loop, we have to use iterator. So iterator will return an iterator, and enumerator will return another object like enumerate. And this will contain two value, like one is I, which will point to the index, and another one is val. Val is pointed to this data. If you see there are two ampersand str is actually the data represented by A, B, C. This double ampersand is the reference, which will point to the location where the A, B, and C is actually stored. And there is no for let involved here. So using alphabets dot iter, which will return iterator, and enumerate, which will return tuple. Tuple contain value index and value. Now once we get the data, we can print it very well. So I equal to 0, then A. This will be printed by normal fashion, like from ABC, from first to last. It won't be printed in a reverse manner. Now let's see some different example. Now we'll see some small, tiny, interesting stuff using the pattern matching. Here we are not going to use if let or while let, but we'll use the traditional match syntax. And I'll show some kind of nice way how we can reduce our code and whenever we are doing the pattern matching. So I define a simple variable x which contains the data 1. So using pattern matching, we can not only compare this enum option or result, but we can compare any variable or any data type also. So here we do match x, and it is immediately completing the missing match arm. That means we have to give the arms for each and every condition. So here we given 1. Still it is complaining about non-exhaustive pattern, because we have to account for that all the number. So one way to write the condition for 1, 2, 3, 4 till this maximum whatever the limit is all available, that would be silly, but there is a simpler way to do that. So I've only given like 1, 2, 3. I want to explicitly print 1, 2, 3. But if it is something else apart from 3, then this is like underscore syntax. This is the exhaustive syntax. For all the values except this 1, 2, 3 will be this anything will be printed. Okay. Now just let me execute it. Yeah, 1 is 1. If you give like it is 3, if you give any value apart from 1, 2, 3, anything. So this underscore is important. It will match, it is like catch all. If you have 1, 2, 3, you can give like specific matching condition. If you want to give a broader condition, broader matching criteria, you can use underscore. Now we can use like this pipe symbol 1 or 2. So we can print this 1 or 2. So this, if this X will contain this 1 or 2, then this will be printed. Now let me remove this entry for 2, we don't need anymore. So now if I do this 2, one or 2. We can provide this range syntax. This range specify like 1 dot dot equal to. If you don't mention equal to, it would be 1 to 4. This means it is 1 to 4. Or this means it is 1 to 5. So if it is 1 to 5, then 1 through 5 will be printed. And if anything else from 5, then this would be printed. And like number, we can specify like character as well. If like X will contain like A, B, C, D, some character, this is not a string. This is like single quote, and we have a character. Like if it is E is in this range A to K, we can give A to K or A to Z or anything we like. So then A to K will be printed or anything else. Now let me execute it. A to K. So similar to integer, you can compare any value and you can give like range like for character as well. Now let us discuss about few more important things related to a struct, how we can use pattern matching and match keyword in conjunction with struct, and we can manipulate the data along with that. Now I define a simple struct type point which contain two attributes x and y, both are integer, and in this line I have initialized an instance of point with some data like 100 and 200 value x and y. So I can use the destructure syntax to convert this xy to another variable if I want to. So in this example, in the right hand side I have mentioned p, that is an instance of struct. In the left hand side I am not given any variable like to denote the point, but I have destructure and store that value to x and y. X and y will point to this individual values. X will contain to 100 and y will contain to 200. In this example, to access x and y, we have to use p.x and p.y. But in this letter destructuring syntax, we can directly access x and y value. This is a very simple example. Let me run it. Here you can see the value for x and y. And we can assign a different variable if you choose so. Now x and y we cannot access, but we make a aliases and we represent by a and b, and we can print it and it will return the same result. Now, as I said earlier, like match statement can not only used to pattern match enum and enum type, which is very commonly used, but also like primitive types, what we see in the previous example, for example, numbers and character. At the same time, this pattern matching is very powerful, which can be used for matching like a struct type as well. This will open the more complexity of pattern matching. You may not see this example in other programming language, for example, JavaScript and other thing. So here, if you notice closely, I've given like a point x and y. and it is not exhaustive list. That's why it is complaining. Now let me handle, because let me handle some other condition. Yeah. So I handle all condition. If you use only xy, so you are matching for any value for xy. But in this case, you are saying that y should be two, because this is where we hard coded at 200. But this can be like 300, 400, something else. So if this condition doesn't match, then where this will be go? That is the reason it will complaining. So this loops, if you closely look, if y equal to 200, then this particular condition will be matched and x value will be printed. Now let me run it. X equal to 100, and this condition won't be matched. But if you give like 250, then this y equal to 200 match won't be matched, then this particular print won't be executed. But in this case, like x equal to 100, then it will go to the next stage for similar to traditional if else condition. Because x equal to 100, it is matching, so y value will be printed, because there is no point to print x, because we know that x equal to 100. So second match arm will be printed like y equal to 250. But if you, let's say this x also 150, so both the matching condition is not evaluated to true. So x and y will be printed. And there is no need to print this, this. If you really wanted to compare any individual value, then you can do that. Or you can directly compare like point xy without giving any payload comparison. Then there won't be any error. Then this line will be executed. Okay. Now let's see one example with the enum type. We have already seen as part of the starting video, like option and result both are enum, how we can handle using if light or else if light. Now we're using create a little bit complex enum which contains some discrete different values and how we can match it. We'll create a type of message enum type which contain different values. One important thing to note over here is that this message can contain 4 values, but the payload inside each value is different. Quit doesn't contain any payload. Move contain 2.x and y. Write contains some text payload or string data. Color contain 3 different integer in a tuple syntax. So this message enum can contain a different type of data structure. If you want to represent different data types, this would be a good example to leverage. So in this example, I using the message enum and color. There are 3 tuple values and both are integer. All 3 are the integer values. So I given this I initialize like message variable with the color type or color subtype of message enum. So I can using this match for pattern matching enum type message, and then you have to give like 3 different all the implementation I have to provide. So I given some print statement. So I have implemented that default logic for all the 4 type. If it is quit, there is no payload. So this println will be printed. It is move xy. So we can access this xy value and write, for example, text and color. Because our variable contain this color type, so we will get RGB and RGB will be printed. RGB. So if you know this syntax, like not only this mesh syntax is simple, but you have to provide all the type, and this is the way you have to match with that which kind of type it is. If it is like struct type, we can give like this curly bracket, and it is a tuple type. So you have to give the space same type whatever you define in enum. By this point, it must be overwhelming to learn various subtleties of pattern matching. But you can always have a reference and look up to the correct documentation to make yourself familiar. It won't come in a day or two, but slowly you'll get used to it. Now let me explore some of the other nice thing about the pattern matching. So here I define a variable add which take 2 argument underscore and y. Underscore means even though you pass like both argument, I am ignoring underscore. So you can use like x here and not print it, but the compiler would complain and throw in warning. But for this example, I am suppressing warning. This is a bad practice. But if you don't want to have the warning, so you can use underscore. That means the value would be ignored. So you can call this 5 and 10, and 5 will be ignored, and this will be printed y properly without having warning. This is the usage of underscore inside a function argument. So nothing fancy about that. Now let me define a numbers. This is a tuple type which contains 3 values. It is not an array. This looks like an array, but it is a tuple type because it is a small curly bracket. Not curly bracket, like parenthesis. We can use like match in conjunction with a tuple. So if you have like 5, 10, 15, we can use first, underscore and last. Let me run it. First and last. Because you want to ignore this value 10. If you have more values after the 5, 10, 15, if you have like other values and you want to get first and last, then you have to put lots of underscore inside that. So 1, 2, 3, I think 30 is not needed. Yeah. First, 3 underscore, last. Similarly, you can access this first and last values. This is perfectly fine. But if you have lots of field, like if you have 10, 20, it will be cumbersome to use underscore and again. For that, you can use 2 dot. So it will as many. So this will be all, the first would be 5. Rest value would be represented by 2 dots, and the last would be represented by this last value. So if you run it, 5 and 25. Now let me demonstrate the other example. We have an option like num, which contain value 5. And this is a bit interesting. So here, like this sum, right? If x may contain value like 1 to 10, then 10 to 20 at rest of the field. So you can provide some if-else condition. Because you can't directly provide condition on top of the option enum type. So once you extracted this value, then you can specify the condition. If x is less than 10, then you execute this statement. If x is greater than, you go to the other condition. And you have to provide the none type. So if x is less than 10, then this statement will be printed. This is much more powerful. This is not comparing this enum data, but it is the payload data. X equal to 5. And if you can not only can compare with the static data, but you can also compare with some variable. This will work same as the previous example, but not only the static data here hard coded it, you can compare with some variable, and this variable can come from any website and API call or some other value. Similar to here, like 357, if is odd. So if x equal to 357, if all are odd, then this is odd would be printed. Is odd. If it is like, let me give like here, it is like 6. Even though this condition is matching, this is odd, is anyway not checking any odd or even. False. Or none. Basically, this is a Boolean thing. You can use true or false, or you can have some additional logic on top of that. You can call some function call and get some data. So you can put this conditional here. This is a very simple example, but you got the idea, I think. So that's it for today. And I would like to give a big thank you to the Rust book, the pattern matching. I'll give the link below, so you can refer that book for more detail. And this, most of the examples are derived from that book itself. So a big thank you to that book, the book, Rust book. I'll give the link in the below. Thank you very much. Have a good day. Bye bye.